All right, so now that we know how to find the inverse of a 2 by 2 matrix, let's bring it back to the context of the course where we're solving systems of linear equations. So let's consider a system. So let's consider AX equals B. All right, so this is a system. We are familiar with solving this type of system. All right, nice things happen if A is invertible. So let's take a look at what happens if our matrix A is invertible. Then what can we do? Well, the first thing I'm going to do is work with this equation AX equals B, and I'm actually going to multiply by A inverse on both sides. So we still have an equivalent expression. So I'm going to say A inverse times A times X equals A inverse times B. Remember, order matters. If I'm going to multiply on the left on this side, I have to multiply on the left on this side. All right. If A is invertible, that means it's a square matrix. So let's look and think about this, what we have here. A is n by n, so that means A inverse is n by n, and B is going to be n by 1. I always like to keep track of what my dimensions are, so that means this is going to be a n by 1. So it's a column vector. All right, well, what about A inverse times A? When you multiply a matrix by its inverse, we should get the identity matrix. So we have the identity matrix times X equals A inverse B. All right, remember, identity is just like our 1 here, so anything times the identity is just itself. All right, so what have we shown here? We were able to solve this system by just multiplying A inverse times B. So maybe we don't have to go through the whole augmented matrix row reduction process if we already know the inverse of our invertible matrix. We can solve a system this way. All right, so something to think about, is this solution the only solution, or could we have infinitely many solutions? Let's find out. All right, so we're not sure, is this the only solution? Maybe there's more. Let's suppose there is another solution and see how it could be different or similar to the one we already found. So we are going to suppose that U is also a solution. All right. Well, if U is also a solution, what does that mean? That means that A times U equals B, right? If U is a solution. All right, I'm going to do the same thing. I know that A is invertible, so I'm going to multiply by A inverse on both sides here. I see I have the identity as we expect. Which means U equals A inverse B. But is not the same thing we got here for the solution X, A inverse times B? These are exactly the same. So what does that tell us? If we're going to use the inverse to solve the system, so if A is invertible, that means that our system can be solved by A inverse B every single time. There's only one solution. So we're always going to have a unique solution if our A is invertible, and that is our next theorem. If A, which we know must be an n by n matrix in this case, is invertible, then the system AX equals B has a unique solution. And that unique solution is always going to be A inverse times the vector B. All right. All right, let's look at a quick little note, something to keep in mind here. If we take A times B, this product, and take the inverse of the whole product, that is not the same as like distributing the inverse. We saw this with the transpose. It's very similar. This is actually the same as B inverse times A inverse. Let's talk about why that is. Why? All right, so let's suppose that all of these components here are invertible. So let's suppose A, B, and the product AB are all invertible. Suppose A, B, and AB are all invertible. Okay, I'm just going to assume that right off the bat. All right, and remember, we're trying to show that the inverse of AB is B inverse A inverse, so that when we multiply AB times B inverse A inverse, we should get the identity if they are indeed inverses. All right, so I'm going to take B inverse A inverse and multiply it by AB. I'm expecting that I should get the identity since we're saying that these should be are inverses of each other. All right, so note in the middle here, I got an A inverse times A. Looks like the identity to me. So we got B inverse identity B. Anything times the identity is just itself. So we just got B inverse B. B is invertible. So that means this equals I. All right, so what did we just do? We just multiplied B inverse A inverse times AB and got the identity out. That means these two components are inverses. So that means AB, the inverse of that, is B inverse A inverse. All right, so next we're going to talk about how do we know if A inverse exists. And so we have a whole process for doing that. So I'm going to do this in another video.